We're going to continue with 4.2 on page 131 of your notes. It says right there, page 131. Okay, this is just more practice on the previous video. So right here, just like before, we would turn 13 to the 1/2 power. The 2 is going to be the new index, so we would just read it as 13 to the second index, or we could just not even write the 2 there, and it's just by default the square root of 13. Now that one does not simplify, because there's no real number that you can, or well, no nice number at least, that you can multiply by itself and give you a 13. Over here, we have 6, which is the base. All right. Now, this 4 right there is going to be the index. If you scroll up a little bit, you'll see that we put the exponent, the numerator, on the outside. So we would simply put this 3 here on the outside as the new exponent. Now here you just have to make sure that you differentiate between these two factors, right? These are multiplied together, so these are factors. They have different exponents. So the first one has a 1 exponent, which means you don't really do anything with it. But the m has the 5/8. So we would rewrite this. We just keep the 9 by itself. We would try to take a root of this. The m is the base, so we put it underneath the root. The 8 is the denominator, so that's the new index. The 5, so we take this entire thing to the 5th power. So moving on to the next row, if we wanted to simplify this has a negative exponent. So this is understood to be over a 1. So you would simply take this entire numerator right here, and you put it in the bottom. So you put 1 over r to the positive 2/3 power, which would give you 1 over the cube root of r. And then once you got the cube root of r, you would square it. Over here, this looks complicated, but it's not that much. So you'd simply convert the whole thing to a square root of a squared plus b squared, like that. We have a couple more examples. So here we say the square root of 10. Write each radical as an exponential and simplify. Assume that all variables represent positive real numbers. Okay, so now in this case right here, there's really not much you can do, because the square root of 10, it's not a nice rational number. Over here, kind of if we do order of operation, well, first of all, let's say we do it the long way. Let's say we say 5 to the 4th power is 625. And then we say the square root of 625 is equal to 25. That's you could do that with just PEMDAS order of operations, right? Now, the way they want you to do it, though, is they want you to use the trick where you're saying 5. Now, because this index is a understood 2 there, we're going to put the denominator of the exponent as 2, and you can see it's 4 there, right? 4 in here, the exponent. So we end up with 4/2. Well, 4/2 is the same as 2, right? 4 divided by 2 is 2, and 2 squared is 25. So they want you to be able to use the tricks with the fractional exponents, or thinking of things in terms of exponents. Okay, so right here, same kind of trick. This is going to be 8 divided by 4, right? Because if I rewrote this in exponential form, we would have 8 in the numerator, and we'd have 4 in the denominator, right? And that's a 4. So 8 divided by 4 is 2, and 3 squared is 9. Over here, same kind of trick. So we have 6 divided by 6, which is 1. You normally don't write a 1, you just leave it. Okay, so the next one we have right here. Now, normally we wouldn't be able to, we can just simply use the product rule. The only difference on this one is you're going to use the product rule with fractions. So this would give you 2 to the 1/2 plus 1/4. So your big problem here is just simply going to be adding 1/2 to 1/4. Okay, so if we have 1/2, least common denominator between a 2 and a 4 is a 4. So we multiply both the numerator and the denominator of this by 2. Sorry. And then we would add that to 1/4. Okay, so that would simply give me 2/4, and I'm just dealing with the exponents right now, plus 1/4, which gives me 3/4. Okay, so here we go. So we end up with 2 3/4. Okay. Now I could rewrite this in radical form if I wanted to. So for instance, I could just rewrite this as the 4th root of 2 to the 3rd power if I wanted to. Now over here, instead of using the product rule, we would use the quotient rule, which means we would subtract. So we have 2/3 minus 7/3. Now in this case, the denominators are the same, so they're like fractions, so we simply subtract the numerators. So we would end up with 5 to the 2 minus 7/3, which would give me 5 to the negative 5/3. Now since it's a negative, we need to switch position, right? So we would take this numerator and we would put it on the bottom, right? So that would give me 1/5 to the positive 5/3 power, right? And from here we would take the cube root. So I could either leave it as this fractional exponent, or I could convert it to a radical, which would be 1/the cube root of 5, and then we would simply take the whole thing, this whole denominator, to the 5th power. Okay, over here we would use one of the power rules. It's not exactly distribution, but it kind of looks like it. And we would, because it's a power to a power, we would end up multiplying these together. So we'd take the x, and we would keep the 1/2, but we would multiply it by 4. You can think of it as 4/1. And then we would have the y to the 2/3, and we would multiply that by 4, which is also understood to be over a 1. Okay. Now, so we want to simplify those, right? So we end up with x to the 4, right? Because 1 times 4 is 4, and 2 times 1 is 2, so we end up with 4/2. And then we keep the y. And then we have 2/3 times 4/1. 2 times 4 is 8. And we keep that over 3, right? Now this one does simplify, right? X to the 4/2 power, that's actually just a 2. So we'd keep the 2. And the y to the 8/3, we keep that there for now. And we put that over a y. Now normally at this point we might think we're done, but in this case we're not quite done, because we have a y in the numerator and we have a y in the denominator. Now the denominator's y, the denominator's exponent, is understood to be a 1. So we have to use the quotient rule in these two y's right here. So we want to take these two right here, and we're going to use the quotient rule. So I'm just going to simplify that off to the side to do side work. So we're simply saying 8/3 minus 1, right? Now 8/3 minus 1, this has to be over 1. Now we want to subtract from this fraction 8/3, so we need a common denominator. So the least common denominator between a 3 and a 1 is a 3. So we're going to multiply both the numerator and the denominator of this by 3. We'll end up with 8/3 minus 3/3. And then we would simplify the numerator, which is 8 minus 3/3. 8 minus 3 is 5. And we put that over a 3. Oops, 3. Okay. So let's rewrite this. So we keep the x squared from this right here, put that on top. And then we also have a y to the 5/3 power. And that's the final answer. And you could write the second part as a radical if you wanted to, but it's often not necessary. This is the product rule again, so you're just simply going to be adding the exponents. So for instance, I would have m to the 3/4 power multiplied by m to the 5/4 power minus m to the 3/4 power multiplied by m to the 1/4 power. So all we really do in this case is simply add those together, and we add those. So we're adding the exponents for the product rule, right? The same base, different exponents, we're adding them together because we're multiplying, right? Okay, so right here is 3/4 plus 5/4, which gives me 8/4, right? So m to the 8/4 minus, and this is going to be 3, 9 plus 1/4. That's supposed to be a 4, sorry, 3/4 plus 1/4, which gives me 4/4, so it's m to the 4/4. Now in this case we have 8/4 minus, and then these are both fourths, right? So they don't quite match, but we can simplify them, right? 8 divided by 4 is a 2, and 4 divided by 4 is a 1, so you don't even need to write that 1 there. But you end up with m squared minus m to the first power. And at that point, you're done. You're in good shape.